The UK is currently suffering from a £12.5 billion road repairs backlog that by recent estimates would take more than 10 years to clear. The reason for this is the process we currently use to fix our roads is laborious, time-consuming, and burns through vast amounts of virgin fossil fuels like petrol, diesel, and bitumen, which are becoming increasingly expensive. To carry out a traditional pothole repair, the material around the pothole first has to be saw-cut, jackhammered, and excavated into a deep rectangular box with vertical edges. This is because asphalt, the material traditionally used to fix potholes, requires compacting with a combination of downward force and vibration to enable the aggregate particles in the material to lock together and ultimately keep water from penetrating the repair and causing it to fail. Roadmender have developed a new type of road repair material known as Elastomac that's different to asphalt in that it's designed as a fast-setting liquid that's waterproof, adhesive, and doesn't require compacting into a rectangular box. With Elastomac, potholes can simply be filled and surfaced over with a fast-setting rubberized liquid that welds itself to the existing road surface, locking out any potential for the ingress of water and extending the life of the road for years to come. The new process has no need for saw cutting and jackhammering, generates zero waste to haul away and dispose of, requires on average 80% less material per repair, is 4 times faster to install, and consumes 80% less energy than traditional pothole repairs. The new material also delivers significant circular economies compared to regular asphalt by using a patented technology that makes it possible to replace around 49% of fossil fuel bitumen or glue in the mix with end-of-life waste tyres otherwise destined for incineration and other recycled waste streams, which not only makes it more sustainable but also makes it more flexible and more durable. Driving down carbon also means driving down costs. A traditional pothole repair team burns through around 42 kilograms of carbon for each square metre of potholes they repair. That's a carbon footprint equivalent to 1,260 single-use plastic bags for every 1 square metre pothole repaired. With an average 2-man repair team fixing 8 square metres of potholes a day, that's the same carbon footprint as they're walking out of a supermarket every day with 10,000 plastic bags and throwing them in the bin. Multiply that by 2,000 repair teams across the country, and you end up with a sector that's currently generating a carbon footprint equivalent to more than 20 million plastic bags a day. Understanding these factors, one can clearly see it's the energy-intensive and time-consuming nature of the process that's ultimately responsible for the sky-high costs associated with road repairs and the £12.5 billion repair backlog we're currently faced with today. If, however, we can move away from asphalt to new flowable repair materials that don't require compaction, we can instantly reduce an average repair team's energy consumption by 80%, cut their costs in half, and lower their carbon footprint by 85%. In addition to road repairs, the technology can also be applied to anything from repairs to ports, airports, bridges, and car parks, to water, telecoms, broadband, and numerous other critical infrastructure assets across the country and beyond. Thanks for watching. For more information, please go to www.roadmenderasphalt.com. Capital at risk.